Okay, on to part 4c, which is a Bernoulli type fluid flow equation. A pipe carries oil density 800 kilograms per meter cubed. Point A, the pipe has an area, a given area. So you've got an inlet velocity, you've got an inlet pressure. Further along the pipe, point B, the area changes, that's good, to something smaller, so we'd expect it to speed up. And the level is 50 meters lower, so there's a 50 meter head, so H2 is 50. Calculate P2 effectively. Right. I'm going to do this a bit backwards. I'm going to list my two equations. So I'm going to say my continuity equation first. And I'm going to say do it this way around, just because you're going to get yourself some marks just by doing this. So that's Q equals A1 V1. Area 1 times velocity 1 equals A2 V2. In other words, whatever comes into the pipe has to go out of the pipe. And then we've got Bernoulli, which is the beast. Look it up on the formula sheet. It'll be on there somewhere, you would hope. Continuity equation and Bernoulli's equation here. And Bernoulli just says that the energy is the same on both sides. So your pressure energy plus rho GH H1, which is the potential energy, plus the kinetic energy, half mv squared, so half rho v1 squared is equal to the same on the other side. We can't create or destroy energy, not even in oil pipes. GH2 plus half rho v2 squared. We'll state some variables. We know that rho is equal to 800, that's the density. We know that the inlet volume A is at A1. Oh, thank goodness they're not just giving us diameter and expect us to work out that for 6 marks. That would be harsh. So A1 is equal to 0.05. We're given an inlet velocity, yeah, V1 is equal to 4. On the outlet side, we've got, they give us the inlet pressure as well. So P1 is equal to 800. Further along the pipe, at point B, the area, A2, changes to 0.002. The level is 50 meters lower, so H2 is 50. Calculate the pressure. We don't know what V2 is, that's easy enough to work out. Calculate the P2, the pressure at the back end. Right, so if we're to draw this as some kind of, I really need to know how to do straight lines. Well, that looks a bit biological, but we'll go with it. Right, so all this carry on is on that end. All this is on that end. So continuity equation first. So A1 V1 is equal to A2 V2. So we're trying to work out V2 here because we don't have it and we need it. So V2 is going to equal to A1 V1 A1 V1 over A2, which is equal to A1 0.005 times V1 4 over A2 0.002, which is equal to 0.005 times 4. Oh, 10. That's convenient. Picked up a few marks there straight away. And that makes sense. You squeeze the end of a pipe and the velocity increases to compensate for the mass flow. Good. Let's stick it into this beast. I'm not even going to try writing this out again. So I see. There we go. Okay, so Bernoulli's equation, stated it there. We need to start plugging some values in. So pressure 1, 800 kilopascals. That's careless, Kevin. 800,000, 800 kilopascals. So as long as you catch it, it's okay. 800, 1, 2, 3. Plus rho GH. I'm not going to bother with that because H1 is 0. So plus a half rho V2 squared, V1 squared. So rho is 800. Check that, 800, yeah. Times V1 squared, which is 4, is equal to P2 plus, now I do need to do this one, this is 800 times gravity, 9.81, times H2, which was 50 meters, plus a half times 800 times V2 squared, which was 10, V2 squared, so 10 squared. Right, I'm just going to rewrite this. So I've got 800,000 plus 400 times 16. So, and there's, for you, put this directly into calculator brackets and all. I'm trying to work off my phone, so I'm taking some silly shortcuts, which is going to equal errors sooner or later. There's no reason why you wouldn't just type that entire thing into your calculator. I encourage you to do so. So 800 times 9.81 times 50, add half times 800 times 100 is 432,400. So P2 is going to equal 800,000 plus 6,400 minus 432,400. Just taking that across to that side of the equation, and then that is going to equal 800 plus 6,400 minus 432,400 is equal to 374. 1, 2, 3. So that's 374 kilopascals. So we've had a pressure drop across it, which makes sense. We increased the velocity, but we've had a pressure drop. Okay, let's check our answer. 374 kilopascals. 374 kilopascals, happy days. On to question 5.